Welcome to my YouTube channel NPTEL classes for solution of chemistry class 11th NCERT problem 7.60. For this problem we need to identify first what we know. We have got a solution of cyanic acid of composition HCNO, and for this solution its molar concentration is 0.1 molar and its pH is 2.3. Now we need to calculate ionization constant of cyanic acid and its degree of ionization in the solution. We got a solution of cyanic acid of known molar concentration 0.1 molar and known pH 2.34. We need to calculate its ionization constant and its degree of ionization in the solution. What we need to know is that what is the relation between molar concentration, pH, ionization constant and degree of ionization. We should be able to relate molar concentration, pH with ionization constant of acid and its degree of ionization. Idea here is that if I look into this question, I have to calculate degree of ionization of cyanic acid. We know for strong electrolytes degree of ionization is 1. So here in the question a sort of hint is provided that cyanic acid is not a strong acid, it is a weak acid. Its degree of ionization will be less than 1, which we need to calculate. And weak electrolytes are bound to follow Ostwald's dilution law, and as per Ostwald's dilution law, ionization constant of weak electrolyte, or I can say weak acid, is equal to C, which is its molar concentration, multiplied by square of its degree of ionization. This relation relates molar concentration with ionization constant and degree of ionization. And in solution of weak electrolyte, H positive ion concentration, in solution of weak electrolyte, H positive ion concentration is equal to product of its molar concentration and degree of ionization. Here I am relating H positive ion concentration with molar concentration of solution and degree of ionization. So these two equations are the required equations which relate molar concentration or else pH, because pH is related with H positive ion concentration. pH is a scale to express H positive ion concentration in solution. So I will say that these two equations are the required equations by which we are able to relate molar concentration and pH with degree of ionization and ionization constant of weak acid. So I will apply these two equations in order to find the ionization constant and degree of ionization. First, I will calculate degree of ionization, because here I need value of degree of ionization to calculate the acid dissociation constant. Alpha will be equal to ratio of concentration of H positive ions and molar concentration. Now alpha will be equal to H positive ion concentration. I will express in terms of pH. It is equal to 10 raised to the power minus pH divided by molar concentration. Now I will substitute given parameter pH and given parameter molar concentration here. Alpha is equal to 10 raised to the power minus 2.34, I guess 2.34, and molar concentration is 0.1. Alpha is equal to, I will solve numerator part of RHS side. It is equal to 10 raised to the power minus 3 multiplied by 10 raised to the power 0.66. I am multiplying by 10 raised to the power 1 and 10 raised to the power minus 1 to the numerator of on the RHS side of this equation, and finally I get 10 raised to the power 0.66 into 10 raised to the power minus 3 divided by 10 raised to the power minus 1. 10 raised to the power 0.66 is equal to 4.5. So alpha is equal to 4.5 into 10 raised to the power minus 3 divided by 10 raised to the power minus 1, and alpha finally will be equal to 4.5 into 10 raised to the power minus 2. You see, from the value of degree of ionization, it is clear that it is less than 1. So cyanic acid, we confirm that cyanic acid is weak acid. This is confirmation of what we proposed about it, that it is a weak acid. Now we will go for calculation of its ionization constant. Ionization constant will be equal to product of its molar concentration. We will again substitute here given parameter molar concentration and calculated parameter alpha. Given parameter molar concentration is 0.1, alpha is 4.5 into 10 raised to the power minus 2 raised to the power square. Ka is equal to 0.1 into 4.5 into 4.5 into 10 raised to the power minus 4. It will be equal to, K will be equal to, I have already evaluated this, it comes equal to 2.025 into 10 raised to the power minus 4. Again here its Ka value is less than 10 raised to the power minus 3. Therefore, it again confirms that it is weak electrolyte, or more specifically I can say it is weak acid. In this way I am able to solve this problem. Let me recall one time this problem for you. For this problem, first we identified what we got. We have a solution of cyanic acid of known molar concentration 0.1 molar and known pH 2.34. We need to calculate its ionization constant and degree of ionization in solution. what we needed to know is how we can relate molar concentration pH with molar concentration and pH with ionization constant and degree of ionization. For that, idea I user is that cyanic acid is weak acid and it is bound to follow Oostwald's dilution law, which relates ionization constant with molar concentration and degree of ionization. Also, for weak acid, we know that H positive ion concentration in solution is equal to C alpha, where C is molar concentration and alpha is ionization constant. Thereafter, I applied these two equations by substituting known parameters, given parameters and calculated parameters, and finally I got value of degree of ionization equal 4.5 into 10 raised to power minus 2, which is less than 7, confirming it is a weak acid, and value of ionization constant I got 2.025 into 10 raised to power minus 4, which is less than 10 raised to power minus 3, again confirming that it is a weak acid. Thank you. This is what I have got for you in this short session. See you next time. Take good care of yourself. Allah Hafiz.